t to the n minus 2 delta t squared plus all sorts of other things, other terms with delta t cubed, delta t to the fourth, etc. And at the end, you will get a term which is just picking delta t from all the factors, which means delta t to the n. Right? This is a very useful formula. If you have forgotten it, when you study the notes, just try to understand it. This is called the binomial expansion. Okay? It was used in one of the problems assigned for last week. You may have done it in your problem hour or have studied it yourself, okay? And we'll use it again several times. Okay, so we know how to calculate c times t plus delta t to the n. And now let me use it. Any questions about this? This is just algebra, just mathematics, okay? Okay? What did I do? I just put there c times t plus delta t to the n. I didn't write all the terms because I know that delta t will become 0 and things will drop out. So I just put the first term there. Okay? Clear? Now let us proceed. Any questions here? You're all following? Yes? Okay. So again, the initial position ct to the n shows up as the first term in the later position. And then there are corrections, all of which involve delta t. So the delta t will also cancel. Okay? In the next term, let me show you what's going on, some more detail. The next term here has some delta t squared and the square cancels. So now I have simplified my formula. V of t equals lim as delta t goes to 0 of c n t to the power n minus 1. Let me write the next term. This is a dot bit that I didn't write because I didn't have space. Okay, it's not important. I'm going to throw it away now. Now, again, I have done the calculation, I have done the division while delta t was still a small number but not 0. I worked out the formula. Now it's time to take delta t to 0. And the result is V of t equals C n t to the n minus 1. So what have I learned? If x of t equals c t to the n, then v of t, or the derivative of this x, is cn t to the n minus 1. Is this clear? Now I have already come a long way. When you first start to take the derivative, okay, it makes sense, you are calculating an exact velocity, etc. Then students start to get worried. Now this is a complicated process. Calculate the function x at t plus delta t, then subtract from it x of t, then divide by delta t, and then do all these calculations, and cancel, and then take the limit. Okay. Are we going to do this all the time? You see, what we are doing is we use our nice, simple procedure to calculate derivatives for a whole class of functions. Now we have learned how to calculate the derivative of a power, t to the n. This means any combination of powers, 3t squared minus 22t to the 15, you can take the derivative of that. Okay? So what one does is, for several important types of functions, one does it just once. Or you don't even do it yourself, except for the most important functions, which you will see in your mathematics class. Okay? Somebody has done it and it's in the books. You understand how it is done. This is how it is done. Evaluate the function at t plus delta t, evaluate it at t, subtract, divide by delta t, and then make delta t go to 0. This is how it is done. For complicated functions, it can be pretty difficult to do. But this is how it is done in principle, and somebody has done it, and it's in tables or books or on computer programs, and then you use it. Okay. In this class, while we are using physics, we will learn how to take the derivative of powers like this. We have already done it. We have just learned it. And then we will learn how to take the derivative of sines and cosines later on. Okay? In extra topics, we will also do the derivative of exponentials. All of that you will do in your maths course. But the important thing is that you understand the concept behind it. This is the concept. Okay? Now, let me go on with a few more examples. If x of t is some function u of t plus some other function z of t, let's say. Okay? Then the derivative will be just the derivative of u plus the derivative of z. Do you all believe this? Does it make sense? Okay. If something is the sum of two things, the change in that something is just the change in u plus the change in v. Okay? If you and I have a common bank account, and we both put or take out money from there, the total in the bank account is what you are doing, let's say u, and what I am doing, let's say z. How much does the bank account, the balance change per unit time? dt, okay? Per month, let's say. Well, it's changing because the amount he is handling changes and the amount I'm handling changes, so the total changes, okay? Since derivatives are about changes, total change in something is the sum of the changes in its parts. This is very obvious. And I could write it mathematically with u, du, etc., but I won't bother. Okay? This means something great. We just learned how to take the power, how to take the derivative of a power. Any combination of powers, sums of powers, we also know how to handle. Okay? If you have a constant in front, like ct to the n, we saw that the c just comes out in the derivative. Nothing happened to the c. Okay? So a constant in front times the power, we know. So we know ct to the n plus kt to the m. Okay? So any polynomial, we know how to take the derivative. Moreover, this binomial formula, which I showed you with multiplying n brackets, happens to be also true if n is not even an integer. This I won't prove, it's mathematics, but you will learn later in your maths course. So, the formula I derived for taking the derivative of t to the n holds also if n happens to be a fraction or a negative number. I know how to take the derivative of t to the minus 2.35. It is simply minus 2.35 times t to the minus 3.35. Okay? So now I can take derivatives of all kinds of polynomials and all kinds of negative or positive powers. That's a lot already. Okay? Now let's see some other things.